Hi, how's it going? So at this point we have GLFW kind of working well enough, and we've linked in the Vulkan library. Awesome. So the next step is we need to create a Vulkan instance. Now a Vulkan instance basically stores any of the per application state of our engine. So what we'll do is, first of all, we will make this member variable here, Vulkan instance. Now we're using the Vulkan C++ API, which is why we have this namespace VK. This comes from the C++ HPP library, which is a wrapper around the C API. The next thing we'll need to do is we'll need to make a function to create the instance. So we'll just declare that here, and then we'll go into our source code. And okay, after we build the window, then we want to make the instance, and then we'll declare the instance down below that function. Okay, so what I'm going to do is I'm going to take the code that is going to be used to make this instance, and I'm going to push that into a separate file. So I'll just add a new item, and this is going to be a header only kind of file, and I'll call this instance.header. Okay, awesome. So the benefit of this is I can write more complicated notes and get them out in separate files and keep the main file clean, basically. This header needs to have access to Vulkan, so I could go, include vulkan.hpp, but it might be a better idea actually to grab all of this and stick this out into a separate file as well. And this is where I'm going to load all my libraries. So link all my libraries, include all my libraries. I'm also going to include IOStream because I want my other functions, my other headers, to be able to print logging information as well. So where was I? Include config.h. Awesome. Good. And now we can, okay, so we've got that. Awesome. Now we can go into this stuff. So what we're going to do is I'm going to make kind of a shared namespace called Vulkan init, and this will be for any creation code basically. And this namespace will be shared by different files. So other files, like when we make device stuff, that will be using the same namespace as well. Okay, so what we want to do is we want to Cool. Okay, so we just take in a boolean to indicate whether we want to print debug messages and all of that, whether we're doing it in debug mode basically, and we also take the name of the application. Okay, no worries. So we'll go to our source, and in the make instance, we'll say our instance is so debug is going to be based on our debug mode, and for the application name, you know what it is. Okay, cool, awesome. So now let's look at how we actually make the instance. Okay, so as we can see, instance stores all of the per application state info. Now, under the C API, this is what's called a Vulkan handle, which is pretty analogous to a pointer. But in Vulkan.hpp, there's a class that wraps around that, which makes things slightly better. So if we go to vulkanhandles.hpp, and it has this instance class. And if we go to VK instance, so see am I rambling? Okay, so see we have the namespace VK, and that's a C++ thing. But then when we go into the C API, it's just prefixed with VK. So this is defined as a handle, and I think if we go to what does Vulkan define handle do, it's just a generic sort of a handle is a handle sort of thing. So we've got handles for these things, and then there are some resources which are non-dispatchable, but these are all examples of handles. So now the next thing we can do is we can query our system and say which version of Vulkan will you support. So what we can do here is okay. Yeah, so as says here, we can scan the system, and this is core as of Vulkan 1.1. What we do is we go enumerate instance version, and we put in a pointer to an integer which will store the result. Now, if I just bring this up. Okay, cool. So we just go down to instances, and yeah, we have enumerate version, and this is described in the version numbers section here. So a version has heaps of different things. From OpenGL, you have a major version and a minor version. Here we have a variant, major, minor, and then a patch. So if we go to, if we go to like the Luna SDK, we're using, this is major version 1, minor version 2, 1.2, and patch 1.98. Cool, so that's an example there. And then the variant is 0. Now what variant is, I believe variant is pretty similar to, like in OpenGL, I have OpenGL standard, then OpenGL ES, and then OpenGL something something. It's like different variants. But Vulkan at this point doesn't have any variants, so variant will kind of always be 0. But as we can see here, it's a 32-bit integer which holds all of that information, and the way that's packed in is into the specific bytes. So for instance, if we want to get the variant, well, we've got a 32-bit number, and the top 3 bits, the left 3 bits have the variant section. So if we take that number and shift it down by 29 bits, well, then that will leave, the bits which get shifted are replaced with zeros. So that just leaves the variant section of the integer. And then very similarly, to get the major version, well, we shift it down by 22 bits, but then those top 3 bits are storing the variant as well. So we need to do a bitwise AND to remove the top 3 bits, if you know what I mean. And as we can see here, there was an original version of this function which was just shifting by 22 bits, but the issue with that was it was still leaving the variant on the top of the number. But remember, we've got the documentation, and that's all well and good, but we can also go, so if for instance we want to get the info about the version, well, basically these operations are defined as macros, so we can control click into there and we can see the same bitwise operations described in the documentation. I mean, that's what the documentation does, it documents. Awesome. And we also have these old deprecated versions are still up above. Okay, so the point I'm getting at is everything matches together. It's also pretty cool to see that there's this, for the Vulkan core.h, there's this definition here, header version 1.98, which that is because that's the Luna G SDK is patch 1.98. Kind of run this right now, fingers crossed. Okay, so as we can see here, we're making an instance and we query the system and we get variant 0, so just standard Vulkan, nothing crazy. Major version 1, so this system will support Vulkan 1.2 up to patch 1.182, which is interesting because Vulkan is up to patch, Vulkan 1.2 is up to patch 198. So my system probably needs an update. Maybe I need to go check my device drivers, see if I can get a driver update and get back to that patch version. Also, as of last night, Vulkan 1.3 was released, so this is a little bit off as well. However, it will take time for LunaG to update their SDK. Yeah, it's cool. Okay, so we've got the version. Then the next thing we can do is we've got two options for how do we use this information. Because we need to create an instance and we need to declare the version that we're going to use. Now, one thing we can do is we can use the latest version that our system supports. It's best practice, well, best practice isn't really that clearly defined at the moment, but it's a good idea to zero out the patch component of the version number, just to make sure that we can support every patch within that Vulkan version. And remember, when we request a version, this is the minimum version that we're requesting. So anyway, so what we do is we take the version number and we bitwise remove the lower 12 bytes. The lower 12 bytes hold the patch version. We can double check this. So if we go to patch, it's just storing, we shift it, or we just store the lower 12 bytes. So to get rid of the patch, we just remove the lower 12 bytes. That's what this not is doing. And then option 2 is we can simply request a lower version. So at the moment, I'm requesting variant 0 1.0 patch 0. So this is like pretty much the most compatible profile. Now I understand it's a little weird. I'm using a Vulkan 1.1 function to get the version number, and then I'm requesting Vulkan 1.0. That's okay, right? It's fine. So then the next thing we need to do is we need to declare some application info. So the way we declare application info is with this constructor here, which takes a bunch of arguments. We take the name of our application, which we're just taking it from the argument, the version number, which we've declared up above, and this version number comes up a number of times. We have the application version, the engine version, and the API version. I believe some of this is, well, it will come down to the specifics of how Vulkan is being implemented in each case, but in this case, I'm just going to keep the same version number for all of them. That's perfectly fine. Engine name, A. We're doing it the hard way. Okay, so that's fine. Awesome. So we've declared the information that that our instance will need in order to be created. Then the next step is we need extensions. Okay. As we can see here, Vulkan is about being as thin as possible. And so if we want something, we have to request it. What I want is for my window to work with GLFW. So GLFW has a number of extensions that it requires from Vulkan. So we just run this function to get the extensions that we need, and then we stick those into a vector of strings. And then if we're in debug mode, we can print that out. So let's run that right now. Okay, good. So what GLFW is saying is, okay, yeah, no worries. We can make a Vulkan thing, but what we need is this surface extension and this Win32 surface extension. Right. I mean, that makes sense. A window is a surface. It extends, yeah, cool. Awesome. So no problem. That's all right. So now we will go in and we've got the info that the application needs, and then we need to create what's called a create info. So the way this works is this is the info which is used to create an instance, and there are a number of things here. So let me just click in. So where are we? This is the instance create info, and it's a wrapper around this VK instance create info. So this is the C++ version. It's wrapping the C API. Click in there. And there are a few other things, right? So we have this S type, which is a structure type, a pointer to the next application, the next instance. So there might be a number of instances created which somehow depend on each other. So that might be useful to set. Most of the time, this will have a set value, and this will have a set value as well, and it'll be a pretty obvious default, like null for next, and go VK structure type. So we have all of these. It's a very clear sort of convention. It's VK structure type something. So what we want here is VK structure type instance create info, I guess. If I can find it. What? How did I miss that? I don't know. I'm going crazy. All right, so the point is, if we were doing this with the C API, we would set this as an internal variable of that structure, and then, yeah. But the C++ API recognizes that it's kind of redundant, and that is included in this instance create flags. It's baked in there. So awesome. I'm rambling. All right, so we have the application info, then the enable. Yeah, the application info is there. The flags is this create flags. Okay, then the layer info. So layers are optional kind of bits which can be inserted. We'll look at that pretty soon. Basically for error checking, and the layers kind of sit in between functions, and they do little internal checks when functions get called and stuff, and they check that states are valid and arguments are valid and everything. And if they're not, then they throw errors and print out information to the console. But at the moment, that'll be in the next video, probably. Right, so then we need the enabled extensions. So we have PP, by the way. P in this API stands for pointer. It's just a naming convention, so this is a pointer of a pointer. So in other words, a array of strings. Enabled layer extension names and extension count, which it's going the other way for these ones. Okay, so extension count is there. It's the size. It's the number of elements in the vector, and extension names is the pointer to the vector contents, so in other words, the data of the vector. Okay, so we set that up, and then we go and create things. So just paste this in. We'll create our instance. Okay, so with the C++ API, we do everything in a try-catch. So if we just click into here, okay, create result value. Just gonna. Okay, so here we have this: if result is not equal to result e success. Okay, there we are. Right. So in the C API, we have these enumerators called VK results, and here they are. Here are some of the most standard ones. But in the C++ API, they have their own codes. And the way the C++ API kind of handles those codes is internally, and it does it by throwing exceptions. So in the C++ API, we go try except, and yeah, I mean, pretty much there it is. Hi, future Andrew here. I got so excited when I was recording this video initially that I forgot to really explain how this create instance function works. If we just hover over it, we see a bunch of things. We have takes in some creation info and an allocator. Let me just paste the declaration there. So we take the creation info for the instance, and Then we have this allocator. Now, what an allocator is it's a kind of a reference to a function which is used for allocating memory. So most of the time we allocate memory with malloc or new or something like that. Although there are a few cases where we might want to have our own memory allocation system. For one thing, if we allocate large blocks of memory, we might have trouble getting a contiguous block. There might be memory fragmentation or something. Or we might just have a very specific type of memory structure that we want, and we want to have the power to allocate our own types of memory. Okay. For instance, there's a library called VMA, Vulcan Memory Allocator, which is pretty good, although it seems to have random errors and things. Doesn't work so well with GLFW, for instance. But anyway, by default, it's null pointer, and that is Vulkan using its own sort of allocator, which is pretty good. And then the third argument is the dispatcher, which is kind of the place where the function is being loaded from. So by default, in this case, it's the static loader dispatcher. In some other cases, we can create dynamic dispatches based around that load instance procedure address, load device procedure address, that sort of stuff. But yeah, there we have it. Now that is how we run this, and we can actually, because of these default values, we can actually just pass in the create info. I'm rambling. Okay, the other thing which I forgot to mention is, of course, when we create this, we are allocating some memory somewhere, right? Because we're using a memory allocator. So we should be destroying it as well. So we'll just go to the source code for the engine. We'll go to the destroy destructor section, and we'll put in some code to destroy our instance that we just created. So again, we technically, at this point, don't need to put any arguments because it's just the allocator and the dispatcher. Okay, so this should work. We run this right now, and excellent, works just fine. Cool, yeah, so that's it. So what we did today is we had a look at kind of what an instance is. We had a look at version numbers and how version numbers are packed into 32-bit integers and how we can unpack them. We had a look at creation info and extensions, and basically we can now create a Vulkan instance. Okay, so I hope you had fun, and I'll see you in the next one. Bye.